Okay, so another part, is stereoisomer. So isomer with same molecular formula, same connectivity but different in arrangement of atoms in space. Stereoisomer divided into two types, which are optical isomer and then the other one is cis-trans isomer. Okay, we look at cis-trans isomer first. So cis-trans isomer, also known as distereomer and also known as geometrical isomerism. Okay, cis-trans isomer can occur at carbon-carbon double bond and also it can occur at cycloalkane. Okay, so requirement for a molecule to exhibit cis-trans isomerism. The first one is restricted rotation about carbon-carbon double bond in alkene or single bond in cyclic compound. So for carbon-carbon double bond and also cyclic compound, they do have restricted rotation. For other molecule, they are freely rotated. Okay, so for carbon-carbon double bond and cyclic compound, they have restricted rotation. Okay, so cis, when a group of atoms in on the same side, trans, same atom or group of atom on the opposite side. So trans, opposite side, cis, same side. Okay. Okay, so for cyclic compound here, okay, so cis, same side. So for trans, different side. Okay. Okay, second requirement, each atom on a side of restricted rotation has two different groups attached to it. Okay, what does it mean by that? So this is where the restricted rotation occur. So for both carbons, they have same group of atoms or same atoms. Okay. Okay, so for example, for this one, so we concentrate at carbon-carbon double bond. Okay, so between carbon-carbon double bond, okay, we need to have similar atoms. So for carbon number 1 and carbon number 2, we do have similar atom, which is hydrogen. Okay, however, in carbon number 2, the group are the same. Both are hydrogen. So this molecule cannot exhibit cis-trans isomer. Okay, no cis-trans. Okay, so in order for cis-trans isomer to occur is, so it need to have carbon-carbon double bond, and then at the carbon-carbon double bond, carbon number 1 and carbon number 2, dia kena ada benda yang sama. Carbon number 1 dengan carbon number 2 ni, dia kena ada benda yang sama. Contohnya macam ni, hydrogen dengan hydrogen. Okay, tapi at the same time, between carbon number 1 sahaja, between carbon number 1, ini dengan ini kena berbeza. Okay, dekat carbon number 2 pun sama. So carbon number 2 ada hydrogen and carbon number 2 ada CH3. Ini dengan ini kena berbeza. So kita kena tengok dua benda lah. Okay, benda pertama kita kena cari yang sama antara carbon number 1 dengan carbon number 2. Kena cari benda yang sama antara carbon number 1 and carbon number 2. Tapi dekat carbon number 1 ni dalam group carbon number 1, ini kena berbeza. Dekat group carbon number 2, ini kena berbeza. Baru dia boleh exhibit cis-trans isomer. That's why this one dia tak boleh exhibit. Sebab dekat carbon number 2 dia ada hydrogen dan hydrogen. Okay. So we look at this one. So kita tengok betul-betul dekat carbon-carbon double bond. Okay, so dia ada hidrogen, so tu yang sama. So this one dia ada satu je carbon. So this one dia ada 2 carbon. So ini dengan yang ini berbeza lah. Ini dengan yang ini berbeza lah. So this one dia boleh exhibit lah sistran isomer. Okay, so kita boleh lukis lah sistran isomer dia. So C double bond C. So this is cis. Okay, so actually we draw this one in 3D because this one is flat. Okay, this one is trigonoplanar. The shape is trigonoplanar. The trigonoplanar means flat. Okay, so this is cis. So for trans, different side, it will be like this. Okay. Okay. For cyclic compound, if it want to exhibit sistran isomer, you need to find anything that is similar. Okay. So for these 3 carbon atoms, there is nothing similar. Kita tak ada apa yang sama pun sebab okay, hidrogen dengan hidrogen samalah. Tapi macam cakap tadilah, dia tak boleh sama between dua ni. So ni dengan ini memang sama. Tapi antara ini dengan ini, dia sama juga tak boleh. So this one no sistran. Okay. Okay, so for this one, okay, it can exhibit sistran isomer. So between these 2 carbon here, okay, so the similarity is hydrogen and hydrogen. And then, okay, dekat group ni dia berbeza, ni pun dia berbeza. So dia boleh exhibit sistran isomer lah. Okay, so we need to draw it in 3D. Actually dia flat. Okay, so nak dapat dia macam 3D, kita kena buat tegak macam ni. So kita nampak lah, dia actually flat. Okay, so here is cis. Okay, and then another one will be trans. So untuk cyclic ni kita akan draw dia macam ni. Actually this one is 3D. Dia flat tu dia punya compound. Okay. So another example. So if it's triangle, for example. Okay, so kita akan buat dia macam ni. Triangle ni dia macam flat. Okay, triangle ni dia flat. So bond ni kat atas. Okay, bond ni kat bawah. So this is another example lah for sistran isomer. Okay. Antara karbon nombor 1 dan karbon 2 ada benda yang sama. So ni 2 berbeza. Ini 2 berbeza. Okay, ni sama. Ni 2 berbeza. Ini 2 kena berbeza. Okay. Okay, next we look at optical isomerism. Optical activity is the ability of a certain crystal of a solution of certain substance to rotate the plane of plane polarized light. The substance that can rotate the plane of plane polarized light are said to be optically active. Okay, so if the compound can rotate plane polarized light, so we call this compound as optically active. So the compound that can rotate the plane polarized light, we call it as chiral substance. Okay. Okay. So a pair of that compound, we call it as enantiomer. So enantiomer are a pair of mirror image molecule that are they are not superimposable. Okay, so dia a pair of mirror image tapi dia tak superimpose. Superimpose in Malay is bertindih tepat. For example, like our hand, okay, our hand, they are mirror image. If we put left and right hand side by side, okay, so it is mirror image. Okay, tapi kalau saya angkat tangan kanan tindih atas tangan kiri, dia tak akan bertindih tepat. Okay, sebab thumb dia akan jumpa dengan pinky. Thumb dia akan jumpa dengan jari kelengking. Okay, ibu jari dia akan jumpa dengan jari kelengking. Dia tak boleh bertindih tepat. So, dia mirror image. Tapi bila angkat kiri pergi ke kanan pun sama juga. Okay, dia tak akan bertindih tepat. Okay, so macam mana kita nak tahu compound tu boleh jadi optically active? Okay, sebab kalau dia optically active, dia boleh ada enantiomer. Okay, senang sahaja bila kita tengok how we want to know whether that compound can exhibit optical isomer or not. So, when that compound is optically active, it will have a pair of enantiomer. Okay, in order to become a chiral carbon, okay, so that carbon must be attached to 4 group or 4 different atoms. Okay, so dia kena ada 4 yang berbeza. Okay, so maksudnya dekat sini, if you see CH2, so this carbon cannot become chiral center. Or if you see CH3, so this carbon is also not a chiral carbon. Okay, so this carbon is a chiral carbon. So normally we will be star that carbon. Okay, so that carbon, okay, so kita akan draw dalam 3D lah. Okay, so this is the first compound. Okay, so dia ada chirality center dekat sini. So this compound can rotate plane polarized light. So this compound we call it as chiral substance. Okay, kalau dia ada chiral carbon, dia boleh rotate plane polarized light. So this compound is optically active. So this compound can have enantiomer. So enantiomer dia adalah mirror image. Dia mirror image. So dia boleh ada another substance. Okay, bayangkan kat tengah ni mirror lah. Okay, so left and right molecule, so molecule A and molecule B, okay, there are 2 different molecule. So we call it as a pair of enantiomers. Okay, they both can rotate plane polarized light. Okay, so we look at this one. Identify chiral center using asterisk and draw the enantiomer for the following molecule. So CH3 cannot become chiral carbon. CH2 cannot become chiral carbon. Okay, this carbon is a chiral carbon because that carbon attached to 4 different group. Okay, so we can draw a pair of enantiomer. So there are 4 different group attached to this carbon. So you can place that one at any bond. Okay, so this one we draw in 3D. Okay, so boleh letak je kat mana-mana. Kalau nak letak CH3 kat atas ni pun boleh, tak kisah, tak ada masalah. Okay, so we draw another enantiomer. So kiri dengan kanan ni adalah struktur yang berbeza Nampak macam sama tapi sebenarnya dia adalah struktur yang berbeza. Okay, so for example this is a mirror. Okay, so for structure 1 is different from structure 2. Okay, so this compound is optically active. Okay, so this carbon cannot become a chiral carbon, but this carbon is a chiral carbon. Okay, so for this one is a chiral carbon. CH3, CH2, another CH3 cannot become chiral carbon. Okay, you can draw a pair of enantiomer. Okay, so there are 4 different groups. So here is hydrogen, but you can rotate. So if you don't want to put hydrogen here, you want to put hydrogen here, also possible. Okay, OH is up here, there is no problem. Okay, so it's entirely up to you where you want to put the 4 groups of atom around the carbon. So this carbon is a chiral carbon, this carbon is a chiral carbon. Okay, same goes to this carbon. So all of this compound we call it as optically active because they can rotate plane polarized light.